Hello friends, it's Friday night coming to you here on Pre-Calculus Network. Some students asked if I could make a video for the review materials, which I think is a brilliant idea. Now you'll have something fun to do on the weekends with your friends. Anything that you're like, I don't remember that, put it on your cheat sheet. That's its purpose. And figure it out. There are questions from chapter 1 that are different than what you see here. So make sure that you're kind of looking at all the things on the list, not just what I'm doing. My dog is chewing on a really loud bone in the background, so you might get to hear that too. All right, first of all, slope-intercept form. Let's hustle our butts here. That's this. And please don't tell me you don't know anything about it because you've been learning it since middle school. In this, it's called slope-intercept for a reason. This is my slope that tells me the steepness of my line. Positive goes up, negative goes down. This is the intercept where it crosses the y-axis, meaning what do you get when you plug in a 0 for x? Very algebra 1. Saw it again in algebra 2. Did it again here in pre-calc. So it wants us to find this slope-intercept form. Okay, well, we need the y alone, and it's not. So let's start getting it alone. We're going to start by adding 9x, I should say. So now I have 3y, and since I have to get mx plus b, I'm going to write the x part in front of the 5 when I add it over. They don't go together because they're not alike because the 5 doesn't have an x. I need the y alone, so I divide each piece by 3. So in the end, and according like what you see on the key, I'm going to have y equals 3x because 9/3 reduces, plus 5/3 because 5/3 does not reduce. So that's going to be my answer to finding it in slope-intercept form. And then it says find the slope and the intercept, but that's super duper easy. The slope is the m, and so that is 3. The y-intercept is the b, so that is 5/3. Write an equation in slope-intercept form. So same thing. It has to pass through 0, -3 and a slope of 7. So we did a chart at the time, and you could look it up in your notes or mine. And it talked about how to find m, how to find b. There were 4 ways to find m, and we just used 1 way to find b. So in this case, they are telling me the slope is 7. And actually, they're sort of telling you the b value, because if you look back at what I wrote here, the b value is what you get when x is 0. So I already know that the intercept's going to be -3 because they told me that when you plug in a 0, you get out a -3. But let's say I forgot that and didn't notice it. This is my formula, y equals mx plus b. So I got 3 numbers, 0, -3, 7. Which of them is a y value? Well, the second one in the coordinate pair. The m is the one they told me is the slope, and the x is the first number in the coordinate pair. And I use that setup to solve for b, except 7 times 0 is nothing, and so I just know that b is -3. So now I have the 2 pieces to my puzzle, and I go ahead and write my equation. Y equals mx, and then my b value, and in this case it's a -3. Keeping in mind that if you were graphing that, you'd go down 1, 2, 3, because it's your y-intercept, and then the 7 means you'd go up 1, 2, 3, 4, 5, 6, 7 over 1 to draw your line. They didn't tell you to draw it. We're just reviewing. Okay, here they're going to tell us to draw it. This one's awful because it goes off the graph, so I already know. I'm going to draw my graph up a little higher. This is my y-intercept, so that's where I'm going to start. It's going to cross the y-axis, so I'm going to start on the y at -1, 2, 3, 4, 5, 6, 7, 8, 9. This is my slope, and it's -1. And since that's a whole number, it's over 1. Excuse me. So because it's negative, I'm going to go down 1, over 1, down 1, over 1. And I'm going to connect those lines, those dots to make a line. All right. I feel like it's time to change colors. There. I feel happy. So again, find slope-intercept form. So obviously, that's going to be on the test. You know what else I would want to know from that? Horizontal lines. Horizontal lines go this way, horizontal. They would only cross, if you drew them, they would only cross the y. So you only get y equals a number. And they have a slope of 0. All right, what about vertical lines? Vertical lines go vertically. And as vertical lines, they only cross the x-axis. So their equations are just x equals some number. And we say that their slope is undefined. So I would want to know that because that is something we talked about a lot at the time. And it may or may not show up on these practice questions, but you want to make sure you know that. Okay, anyway, slope-intercept form. So we've got an x, a y, and, it says it's perpendicular to this. So on that chart, it talks about the 4 ways to find slope. Either it's given, you use the formula, it's parallel to something, or perpendicular. Perpendicular means that you need to use the opposite, meaning plus, minus, and the reciprocal, meaning you're going to flip it over, whatever they were giving you. So like in this equation, the slope is 2, but we're not going to use 2 because we need to use for perpendicular the opposite reciprocal. So we flip it over and change the sign, and we'll be using -1/2 as our m value. We're given an x and a y. So just like I showed you up above, you're going to go y equals mx plus b. This is like being over 1, so I turn that into -4/2, but -4/2 reduces to -2. Add that to both sides, and b has a value of -1. So between that and this, which I figured out from the perpendicular business, gives me the two pieces I need. Y equals mx, and then my b value. And if I had to graph this one, it would start at -1 on the on the y, and go down 1/2, down 1/2 to generate a line that has that equation. Okay, this one's parallel. So what does that mean? That means I'm going to use the same slope. Well, I got to figure out what it is because this one's not in slope-intercept form. So just like in the very first equation or question, I think it was, we had to do this. So I have -7y equals -2x minus 6. And I have to divide everything by -7. So this is pretty unpleasant. So the equation of that line I don't really care about. What I care about is this part, because it says it's parallel to that line. So if that line has a slope of 2/7, I need to have a slope of 2/7. So I already know that my slope is going to be 2/7, which means it's not choice A because that's negative. It's not choice C because that's 7/2. It's either going to be B or C because they both have 2/7 as a slope value. So I'm going to have to go back and use the x and the y that they gave me to figure out the b value. So y, which is 4, equals m, which is 2/7, times my x, which is thankfully 7, because that's no big deal, then the 7s will cancel, plus my mystery b value. 7s cancel. I have 4 equals 2 plus b. So taking that 2 away, I get a b value of 2, not a half or -1/2. So in the end, b is the correct line. That will go through 7/4 and be parallel to the line they gave me. So again, there's so many common themes. If you see it repeatedly on the review, you're going to have to know it. Parallel, perpendicular, neither. So they're giving me 2 sets of points. Here to find the slope, I'll need to use my slope formula. And if you're like, oh, I always forget that. Hey, I have an idea. Put it on your cheat sheet. What a nice thing that you get to have that. So for line 1, I need to go through these points. This will be my first x, first y, second x, second y. So the slope of the first line will be y2 minus y1 over x2 minus x1. Be careful with the positives and the negatives. Up here, you're going to have minus and negative, which turns into adding. So I end up with 1 over 5. I don't actually know anything about it based on that. So I have to go back and find the second slope and compare them. So let's take a look. Here I'd have this as my first x and my first y, my second x and my second y. So y2 minus y1 over x2 minus x1. This is just a 1. This changes to addition. And in this case, because they are the same slope, that would mean that they are parallel lines. They will never cross. They're both going to go up 1 over 5, up 1 over 5, forever and ever. All right. Okay, what does it mean to be a function? Well, in this particular case, I have to decide if it's a function or not because I can have no repeat x's. So if an x goes into my function as a certain value, it cannot come out as two different values. So I look, 5, -9, 5. Okay, that's not a function. And this one is the one that is a function. So that can't be right because 5 went in and came out as a -9, and then later 5 went in and came out as a +9. That can't happen. How about my x's here? 5, -9, +9. That works. C doesn't work because it's not even ordered pairs, so it doesn't even make sense. Here's ordered pairs, 5, -1, -1. There's the problem. Those repeat. -1 came out as a 9. Later, the same number came out as something different. That can't happen. Now, the y's can repeat, so I never even look. All the y's could be 2. Doesn't matter. But the x's cannot. Keep in mind, this is also when we use the vertical line test. If we had graphs, we would use a vertical line test on a graph and be like, oh, hey, this passes a vertical line test, so that's a yes. But this weird sideways graph fails the vertical line test, so that is not a function. So that was another way we tested it. And if you look on your list, it's going to say, is something a function or not? Determine if it's a function or not. Domain and range was a huge part of chapter 1 and has carried on ever since, so don't delude yourself into hoping it's not on the final. This also goes back to remembering how to graph stuff. You have to know some of these parent graphs. Where's some blank paper? You have to know that this is linear and we'll just make a line. By this point in your math career, you just kind of have to know that. This is a square, x squared. That'll create a parabola, and that is called quadratic. Anything that has that. We did these. It's called absolute value, and they make a V graph. Then like a square root makes a little hook like that. Doesn't go back down. It just kind of keeps going up slowly. It's a bad graph. And so you're supposed to kind of know those. I always called them containers, if you remember. And what I mean by that is the container, the thing that it is, the square, the root, the absolute value, determines the shape. Then we did a thing, and there's notes on this online, where we looked at what if I have a number out here? What if there's one here? How about here? How about out here? So even though I'm using absolute value here, it could be anything. It could be this squared. It could be square root, any of these containers. These numbers all do the same thing. Some move them up, down, left, right, all that good stuff. So you have to look that up on the notes and get that onto your cheat sheet if you don't remember that off the top of your head. So in this particular problem, this is like having +0 at the end. So what I learn and remember from this is my vertex would be the opposite of this number and then the number on the outside. And then this is like the slope of the right side. So if I get myself a little sketched up graph here, -8, 1, 2, 3, 4, 5, 6, 7, 8, 0. That's my vertex. I look and go, oh, it's absolute value, so that'll be a V shape. The slope of the right side is 4, so up 1, 2, 3, 4 over 1, and up 1, 2, 3, 4 back 1, because I know that this has symmetry around that middle line. Okay, now I can do domain and range. Domain is from left to right. This graph goes forever to the left, forever to the right, so -infinity to infinity. You can never get to infinity, so you're going to use parentheses. The range is from the bottom to the top. So this is from left to right. This is from the bottom to the top, the y's. Well, the lowest this goes is 0, but it actually hits it, so it's included in the graph, so I use a bracket. And then it goes up forever, but you can never get to infinity, so you leave it as a parenthesis. This one would be tricky, except for they graphed it for us. So now we can just use the graph. So in this case, I believe these are meant to be arrows, so we'll just treat it like that. So domain, left to right, goes forever left, comes up, back down, but while it's going up and down, it's also going left to right forever, so all real numbers or infinities. The range, however, the lowest it goes is forever, so it's down forever at the bottom, but it tops out right here, which is at -1, 2, 3, 4. And it actually touches -4, so that's going to be included. Is this graph a function? Why or why not? What do you think? I think yes. Because if I imagine those vertical lines, none of them cross through it in more than one place. So when it says why or why not, my reasoning would be that it passes the vertical line test. Okay, so this is intervals. Intervals are a big deal. Some of what we've looked at, like slope and parallel and perpendicular, that is like super duper algebra 1 and algebra 2 and even geometry. So this was one of the things we learned that is strictly pre-calc. Like this is not looking back, this is looking forward. Intervals you describe using X. And we need to be able to tell when is a graph going up from left to right or down from left to right or straight across. This is a parabola. I already know that because the container is a square. And so I have to go and think about what I know about these. And we learn these later on in one of the chapters too, that the vertex here, this is in vertex form. I would take the opposite of this as my X coordinate and then that number as it appears. And then the fact that it's negative means it's going to open down. So I can get a good sketch of this, or I could type it into my calculator. But I know that at -1, +1, 2, 3, I'm going to have a vertex, and then my graph is going to open downward. And I know it's a parabola because that's what that container of squared X means. So you do have to put a lot of thinking together. So think about where it changes. It always changes at a max or min. This is a max simply because it's the highest point. I think, okay, that max is occurring at -1, 3, but the only number I'll use in my description of intervals is -1 because I always describe it using X's. So you have to look at each region. So this is the left end, we call it -x. This is the right, negative infinity. The right end we call positive infinity. So our two intervals are to the left and the right of this -1 value. So to the left of it, over here, the graph is increasing because when I get on the graph, I go up. To the right of that, when I see the graph, it's going down. And so that's going to be decreasing. So when it asks me for the interval of increase, where's that happening? Well, everywhere to the left of -1. So from negative infinity to -1. And it's not really included because when it hits that spot, it's no longer increasing, it's turning around. Then it comes back down. So the interval where it's decreasing is from here over to the right. So from -1, because we always use X values, forever to the right, which is infinity. So these are considered my intervals of increasing or decreasing. All right, graphing utility, that's very fancy. This means to use your calculator to find any relative min or max values. It says to use 3 decimal places, but I think they actually came out to be nice and even. So if you don't remember the steps to doing this, in the folder, chapter 1 folder, in the filled in notes, you're going to find something that says calculators, finding calculators, max min on your calculator or something like that. We did this for a couple of days and you guys just have to refresh your memory on the keystrokes. So the first thing I'm going to do is go to y equals. I'm going to type this in. Keep in mind, I'm going to use to get an X, I use the button that says like X, comma, T, comma, theta, comma, N or something like that, kind of up towards the top left. Make sure on your graphing page that none of your plots are dark. When you hit y equals, it should say plot 1, plot 2, plot 3, but none of them should be dark. If they are, zip up there using your arrows and deselect them, get them to go away. So I type in my x to the third minus 6x squared plus 2, and I hit graph. If my computer, like my calculator screen is weird, I just go zoom 6, the key that says zoom under the window, and then the number 6, and then it'll go back to normal. And then looking at mine, I'm just kind of sketching it. It looks like this, but I can actually only see like this much. So this part at the bottom is gone, but I'm smart enough to know that what goes down has to come back up if I see it here. So it's asking to find any max or min values. Okay, max values are the y coordinate. They don't want to know where it happened. So I got to find this because that's a max. That's the highest in the region. It's not the highest forever because this goes up. And then this is a min. They're like peaks and valleys, the highest and the lowest in their given region. So how do I do it? Well, go back and look at those notes. But I basically go to second trace. And then in this case, second trace, I'm going to pick max. And then it's going to lead me through what to do. It says left bound. So I go and make sure my cursor is on the left of that max. Then I go to the right. And then I hit enter again. Ask me if I want to guess. No thanks. And now be careful because it says like 1.0256, but then it says E negative 6, which we talked about in class, and it means 0. And then the y is 2. Well, that seems reasonable. But when you're asked for the max value, you have a max value of 2. It's the y coordinate. How high does it actually go? What's the highest it goes, the max value? Then I'm going to go back and do the same thing, second trace, but now I'm going to pick minimum. Now my minimum's off the screen. So when it says left bound, I just want to be somewhere over here because that's to the left of the minimum. And then I hit enter. Then it wants me to do right bound. It goes off the screen, but I just wait for it to come back as I use my right arrows. Then it comes back over here somewhere and I hit enter because that is the right of the minimum. I don't want to guess, so I hit enter again. And it tells me that the minimum, mine is showing 3.9 repeating and then negative 30. So this goes down really low. Basically at negative 4, it goes down to negative 30. So my actual minimum value will be negative 30 because that's how far down it goes. I don't care that it happens at negative 4. I care that it goes all the way down to the lowest point at negative 30. Comes up to the highest point of 2. Okie dokie, Smokies, piecewise functions. These are always tricky, but they're exactly that. They are pieces. They are rules in pieces. So use your matchy-matchy self. See where they split. These split right here, meaning that's where your breaking point is and the two pieces come together. That happens at 1, x equals 1. That's why all of these say 1. Makes sense. This side over here are x's that are less than 1, and these are the side over here are the x's that are greater than 1, because this would be 2, 3, 4, 5, 6, 7, all the way out to 10 and beyond. See how this bottom piece is filled in and this one's open? That means this one down here is true for x's less than or equal to 1, but the right piece over here is only true for x's strictly greater than 1 because it's open circled. All right, well, this left piece is horizontal, and I already talked about that. What's the equation for a horizontal line? Well, it's just y equals, and then the number it hits the y-axis at, which is negative 3. So keep in mind that these are all really just like saying y equals, and there's two pieces. So we need our left-hand piece for x's less than or equal to negative 1, meaning the left side of that break, to be y equals negative 3. Okay, that works here. That works here. What's wrong with C? I've got the negative 3, but this is telling me it would be to the right. X is greater than 1. Not true. What about this one? Same issue. It's saying that the negative 3 is going to happen to the right, so it would be over on the right side of my graph, but that's not what happens, so it's either A or B. So then let's look at the other piece. The other piece is for the right part, which is past this, so x greater than 1, so that, so I'm actually already done. This says for x is less than 1. Well, that would be over here, but we want the x is greater than 1, so that's already wrong. So I already know my answer is B, but just so you can figure out how to find the equation, I just count on here. Now I wrote all over it, so it's hard to see. But I would just be like, from a point on here, how do I get to the next one? Down 1, over 1, down 1, over 1, down 1, over 1. So my slope is negative 1. Okay, well, that's true here and here. And then where would it cross the y? If I extended back this way, it would cross at 2. So that's where this came from. So even though the equation negative x plus 2 is the same, this one's saying that's on the wrong side of our vertical breaking point. We need the one where it says it's on the right of it. So B turns out to be correct. Even, odd, or neither. Okay. So again, to check this, what you do is you plug in a negative x. And you remember that a negative x to an even power will come out positive, but if you plug in a negative x to an odd power, it will come out negative. That's going to be a key thing to know. Put it on your cheat sheet. If when you're done, what you get is the same as the original, then it's an even function. If what you get is the total opposite, every single term has changed signs, then that's going to make it odd. And if you have a mixed bag where some of them became positive and some became negative and they aren't the same as the original, but some are, then that's neither. So this is our original. Alrighty. So I need to go through, and where there was an x to the fifth and an x to the third, inside those parentheses, I'm plugging in a negative x because that's how you test even, odd, or neither. So let's go through it. This part, negative x to the fifth, because it's a negative to an odd, is going to actually turn out to be negative, but gets multiplied by a negative 5, so I get 5x to the fifth. This part is also a negative to an odd, so it'll stay negative, but then it gets multiplied by that and turns positive. So now let's compare. This negative 5x to the fifth has completely changed to positive. This negative x cubed also changed. So we're in this position where it's the total opposite of the original, and that means that this is an odd function. Okay, this goes to transformations to graphs. So again, you might need to dig out your notes, the ones that I was referring to over here. This is all about transformations. Where does it go left, right, up, down, and so on? And there's a whole filled in notes on that transformations. So I need this container, x squared, but I'm going to go 2 units to the right and 3 up. All right. So I'm not going to have any change in shape. So out in front, I'm not going to have anything. Then my container is squared. To go 2 to the right, that happens inside. But if you remember, it goes the opposite of what you would think. So you would think if you're going to the right, that's positive. But to make that happen, you use a negative. To go 3 up, though, since that's on the outside of the container, you put exactly what you think you would. So that would move the whole graph 2 to the right because of this, and then up 3. Okay, reflection is getting flipped over. A reflection over the x-axis means that instead of your parabola looking like this, it's going to get flipped over and look like this. That happens if you have a negative a out front. So here the a is on the inside. That's not right. Here the negative's on the outside, but you're flipping this original equation. So moving it is not the same as just reflecting that original one. And here you have the negative inside and you're still moving it left and right. So a is the one where you're taking the original function of plain old absolute value x and you're flipping it over the x-axis by putting a negative out front, which is coming back to this also, knowing what those pieces are. So know that, have it in front of you and know how to use it. Now we switch gears away from the graphing and we talk about functions. And in functions, this is f minus g. Well, function f is this rule and function g is this one. So with subtraction, you literally take function f and you subtract function g. Now the parentheses are actually important because you got to distribute that negative. It affects everything after that. So minus 5 and then plus x because a minus and negative turns positive. And then all you have to do is write it in proper order, meaning highest power of x first, then the next power of x, and then you have a 25 minus 5, so that would leave you with 20. So write it in standard form, highest power on down, because we're in pre-calc. What's this fun thing? Okay, so I don't have, whoopsies, I won't have enough room here to do this, so I'm going to cheat and do some of 17 down here. I'll leave a little space for 19. So 17 gave me my two formulas. 5 minus 2x is f. X squared plus 2 is g. It wants me to do this. That is not multiplication. We also wrote it like this, a function within a function. It means that you're going to take all of g and plug it into f. So what does f do? Look up at 17. F takes 5 and subtracts 2 times whatever you're plugging in, and what we're plugging in is all of function g. So looking at 17, what does function g do? It's an x squared plus 2. So I am plugging g in to f. So I'm putting it in where there used to be an x. And now I just do math. This distributes, and then I write it as simplified version. So 5 and a negative 4 becomes 1. So this is going to be f of g, but it also asks for g of f in part B. Okay, so in part B, I'm going to do the exact opposite, g of f of x, which might be written as a g on the outside because you work your way from the inside out. But g of f of x is going to do the exact opposite thing. It's going to take all of f and plug it in to g. Well, what does g do? One thing that g is going to do is it takes whatever you plug in and squares it. Where did it go? And then it adds 2. Okay, well, what I'm plugging in is function f. So 5 minus 2x. Now, you are probably not going to love this, but we are smart enough to do this. Squared means multiplied by itself. So I'm actually going to end up foiling those two. And then this plus 2 is going to be hanging around at the end. So let's FOIL this. 5 times 5. Outside is negative 10x. Inside's another negative 10x. So I get negative 20x. And then plus, because negative times negative, 4x squared, and then plus 2. So let's write that in order. Highest power first, next highest power, and then 25 plus 2. So those are easy or difficult depending on what you're plugging in. Okay, so this is the same thing, but this is easier because I'm starting with a number. If you start with a number, you're going to end with a number. So I'm putting negative 4 into g first. So where there used to be an x, I put a negative 4. So I get negative 12 plus 6, so I get negative 6. But that negative 6 is not your answer. It's telling you to take that now and plug it into this rule. So 3 times negative 6 plus 6, which is going to be negative 18 plus 6, so negative 12. That's fun when you just have a number because it's a bazillion times easier. Yay, grand finale number 19. Okay, inverse. F inverse looks like that. And you get it by swapping the x and the y. And then solve for y. So currently this is y equals 2x plus 1/3. I'm going to swap it out and make it x equals 2y plus 1/3. And I'm going to do algebra to get the y alone. I'm going to start by subtracting the 1/3 over. So now I have x minus 1/3 equals 2y. So I have to divide by 2, which is the same as multiplying by a half. But then you have to do that by every single thing. So I end up with 1/2 x. And then these 1 times 1 on top, 3 times 2 on the bottom. And here they cancel. And so this is my inverse. And you might see, I'm not sure what I wrote it like, but I might have written it as x over 2 or like this is the same thing. And there you go. And then I just use that fancy notation. So it's definitely a lot, and probably 1 and 2 are going to be, the trickiest because they're so far in the past. I will make a video for number 2, but it's really late for old gals, so I'll probably do that tomorrow morning for you. and get that posted. And then that will give you something to do on Saturday night. Watch my videos. Alrighty.